What we're going to do now is talk about rate laws, which have to do with the mathematical equations related to these reactions. Okay, how can we use kinetics to figure out how fast these things are happening and what do these rates look like? Okay, and so I showed you earlier in the previous video that you can mathematically define the rate as being related to the changes in the concentrations or the amounts of things that are present. But what I really want to do is relate these things not to like time-based quantities, but more like concentrations. Okay, and so to do that, we're going to use something called a rate law. So let me show you what this rate law looks like. It's found experimentally that you can think about the rate of a reaction as being proportional to the concentration of each reactant raised to a certain power. Okay, and so I can say that the rate, which is given by the Greek letter nu or v or r, is equal to some constant k times the concentration of A to the x power times concentration of B to the y power. This assumes that I have two reactants, A and B, that are forming products. Okay, so some things to note here. The K is something called the rate constant. And that gives me a measure of how quickly this reaction is happening. And the x's and the y's, these exponents here, are called the orders of the reaction. Okay? The orders are not necessarily the same as the coefficients when I balance the chemical reaction. They might happen to be the same as the coefficients when I balance it, but they don't have to be the same. Okay? It really depends on the experiment and what the actual reaction is. The only exception is if you see the word elementary written in the question. Okay, if you see elementary, then the orders are the coefficients when you look at the balanced chemical reaction. Okay, or if they show you a mechanism, which is a series of steps, then for each of those individual steps, you can assume that the coefficients are the same as the orders. Okay, but in general, the orders could be anything. It could be 0, could be 1, could be 2, could be a fraction, could be negative. Okay, I don't know, it could be any number that you want. Okay, however, for the CLEP exam, we're going to focus on a few different possibilities. So the order is almost always going to be either 0 or 1 or 2. That's it. Okay, those are the easiest ones. The overall order is just the sum of x and y. Okay, and so for example, if I had something like the expression rate is equal to k times the concentration of A, this is said to be first order because the exponent for the A is 1. But if I had something like rate is equal to k times A times B, now I can say that this is first order with respect to A because there's an exponent of 1 there, and first order with respect to B because there's an exponent of 1 there, but second order overall, right? If I add 1 plus 1, I get 2. Okay, so that's how you can figure out the order for a reaction.